Element number one on the periodic table is hydrogen. This is Norris Teaches Science with me, Mr. Norris, and this is a physical science edition of my videos. Today we're going to talk about what physical science is. It's one of the um, sciences you can study in school. Where I teach, we teach this in high school, as well as some of it can be taught in the lower grades. But in this video, you should be able to say, I can understand what physical science and basic science procedures. So, what is science? I like to start off with this slide when students are new to the school or new to high school, because physical science at my school can be taught in ninth or 10th grade. Or taken in ninth or 10th grade. So, science is a system of knowledge and the method used to find that knowledge. So, it's the knowledge and how we find the knowledge. And most science begins with curiosity, wanting to know something, and it usually ends in some type of discovery. And so, I'm hoping by the end, by watching these videos, you discover something as well. And it can be small, it could be big, but always discover something. So, what is physical science? Physical science is a broad range of studies that focus on non-living things, things that are not living. So we will not be talking about animals in here or cells or any of that. Now, when we talk about physical science, you can talk about with the chemistry section or the physics section. They work together in the end, but it brings chemistry and physics together. Chemistry is the study of matter. Um, so its composition, its structure, its properties, its reactions. Chemistry studies that, while physics studies matter in how it works with energy, with motion and force. So let's look at these topics. Let me get the pen out. All right. We're going to match the topic to the branch. So I'm going to write C for chemistry, P for physics, or B for both. So an atom, we're really going to talk about that in chemistry. Bonding, that's going to be more of a chemistry. Work, we're going to talk about that in physics. Power is going to be another physics. Boiling point, you can probably talk about that in both. Waves, we're going to talk about that more in the physics sense. Magnetism, more in the physics sense. Phase changes, we're going to talk about in both. And the periodic table is more of a chemistry section. That's how we're going to talk about them in these videos, because I really break them down and talk about some chemistry and then I talk about physics, but we do try to interrelate them. So when we talk about science and we do science, we do the scientific method, which is an organized plan for gathering, organizing, and communication of information. So it's planning out how to get information and how to get that out to other people. So the goal of any scientific method is either to solve a problem or to better understand something. So the steps to the scientific method, these are just 6 generalized steps. The first thing you're going to do, you're going to start with your question. The question is, what do you want to find? After the question, you're going to do research. You have to educate yourself. You have to find more out about your topics from your question. After you have some knowledge, you're going to make a hypothesis, which is a guess. After the hypothesis, you're going to do the experiment and collect data. After the experiment, you're going to analyze your data. You're going to analyze it. You're going to use graphs, charts, all that. And then you're going to come to a conclusion. Were you right? Were you wrong? If you're right, why were you right? If you're wrong, how can you make your hypothesis? How could you rewrite your hypothesis so it is right? Now, I talk about hypothesis, and it's an educated guess to answer a question. It's educated because it has to come after research. But hypotheses grow into scientific laws, and this is how it does it. After the hypothesis, you come your theory, which is a well-tested explanation of observations. It means you have tested your hypothesis multiple times. But a theory is not widely accepted by everyone in the scientific community. There's still people who say no, and they're trying to disprove your theory. A scientific law summarizes pattern in nature. They are usually the last step, and they're about 99% true. We don't say they're 100% true because there could be a time when we could break that law with an experiment, and then we have to start all the way back over redefining the law. So, like the Big Bang Theory from Earth science about how the universe started, it's a theory. Not everyone believes it. But the law of gravity, most people believe that. If you want to test it, stick something out over your desk, drop it. If it falls to the ground, there's gravity. Now, parts to an experiment. An experiment is when you test a hypothesis. And when you do an experiment, you're going to have trials, which means you're going to test it repeatedly. The best result in a scientific classroom would be 3 times, but in the real world, they're going to test it multiple times just so they have enough data. Also, you're going to have variables. Variables are factors you change, and there's 2 main types you can have. Independent variables, which those are the factors you change. We also call them manipulated variables. And dependent variables, these are factors that change because you did something. We also call them the responding variable. Data does come when you do an experiment. It comes in 2 forms. You have qualitative, and I have the L capitalized over here because you're going to use your language skills with qualitative data. This is data in the form of words, like Mike has a blue shirt. While quantitative data that has an N in it, it's data in the form of numbers. And so we're going to take those usually with measurements. Or like my example, there are 14 tables in the house. Graphs are what we use to express and analyze our data. And there's 3 main types of graphs. You have the line graph, the bar graph, and the circle graph. In graphs, you have 2 parts. You have the x-axis, which is horizontal. That means goes left to right, right to left, goes across. You place your independent variable, the variable you change purposely on the x-axis, and usually time, months, colors, those are usually the ones you would see on the x-axis. The y-axis is a vertical, or it goes up and down, up and down. And you're going to place your dependent variable is the responding variable, or what happens because of you doing something. And usually stuff like distance and temperature will go on the y-axis. Now the 3 types of graphs are line, bar, and circle. A line graph is used to show how things are related. Usually we use line graphs for time, and line graphs can come in 3 versions. You have a direct proportional, means as one increases, so does the other. So that's why you have this line going straight up. You have an inverse proportional line graph, where as one increases, the other decreases. And then you have a constant graph, as one increases, the other stays the same. Bar graphs are used for comparing measurements. So we compare. It's all about comparing with a bar graph. And so you usually have, and you know it's a bar graph because it has bars. In a circle graph, some people call them pie charts. It shows part to whole relationships, or how a little bit is related to everything else. We usually use percentages in circle graphs. Physical science, you're most likely going to be using a line graph. Line graphs are really important in the physical sciences because a lot of that stuff requires time. But sometimes you do get to use the bar graph. Circle graphs in class we won't make. They are more computer generated because they're a little difficult to do. But I hope you learned a little bit about what physical science will entail, and some of the stuff about experiments. We're going to be covering a whole bunch of different videos in here. So I hope you come back and watch more physical science videos.